Training objectives today. We want to understand the design principles and operation of HDR treatment applicators and transfer tube. And we're going to talk about how to perform acceptance, commissioning, and QA tests. And that includes the mechanical use and assembly, the physical geometry, the source positioning and travel of the source through the applicator, and also quickly talk about how to perform acceptance testing, commissioning, and QA on transfer tubes, which is very important. I had a transfer tube just fail on Friday in my HDR treatment, so very important to keep them checked. And then understanding sterilization, handling, and applicator shelf life. Next slide, please. So when you get your applicators delivered, there is commissioning and QA that you need to do. And I'll just mention every test here in this slide. First, when you get delivery, you have to take inventory, because as things get packaged, sometimes little bits and pieces are missing. You will then do a visual inspection to make sure that nothing got damaged in transport. We'll do some functional tests that we go in more details, some imaging tests. We'll do autoradiographs and determine offsets. We test that the transfer guide tubes couple correctly to the applicators. Once we have the applicators themselves tested, we're going to go to the treatment planning system and check that the applicators are correctly reconstructed there. Most of the treatment planning systems these days have solid applicator template libraries that are available, and I very highly recommend using them because that can prevent errors, as I also saw last Friday in my center. We also talk the delivery verification of applicator plans via autoradiography. Talk about some dosimetric tests. You have to train physicians and associated staff in applicator use, and we're going to develop an annual QA program for the applicators. And lastly, but very importantly, sterilization. Next slide, please. So inventory. I have an Excel spreadsheet for all of our applicators that has the model, the serial number, the number of parts, when I commissioned it, and the dates for my annual or quarterly QA. In the directory where that spreadsheet is located, I also put any reference documents that the manufacturer gives me for that applicator, the instructions for use and the sterilization instructions. And these contain technical diagrams of the applicator geometry. In that Excel spreadsheet, of course, is all the list of applicator components, and I mentioned sterilization instructions. So for each applicator, you have to look at your shipping manifesto, at your order form, and verify that they indeed gave you the correct model and the correct components, and cross-check that with manufacturer specifications. If there's missing components, now's the time to mention that to the manufacturer, and they can send you the missing components. Next slide, please. So the visual inspection. AAPM Task Group 56 has a little table that talks about this. So we first look if any of the applicator elements got damaged, or if the structural integrity is compromised. On the right-hand side in that picture with the red arrow, you see a cylinder that is clearly not straight, even on visual inspection. And then you need could either measure the individual cylinder elements to see if they were correctly manufactured, or check that central tube to see if that got bent in transport. So structural defects, see if you can see any hairline fractures in the smaller applicators, sharpness and straightness of needles. Needles often come sterilized these days, so it's a visual inspection. Look at the integrity of the components. Are the O-rings torn, and are the applicators still waterproof? Measure the dimensions. When it says it's a 3 centimeter cylinder, make sure it's indeed a 3 centimeter cylinder, and also the ovoids. External dimensions, compare these to the technical drawings, because, for example, my applicator vendor has 2 versions of tandem and rings, and they're about 1 millimeter different on the outside. And we had the original version originally, and then pulled everything out of the clinic and put the new versions in. And so we verified every single applicator to make sure we have the correct ones. Internal length, these applicators usually come with some device that you can measure the length with. It's usually a wire. that's either connected to a ruler or has a mark that tells you how long the applicator transfer tube combination should be. And so you're supposed to measure the channel length, depending on which vendor you have, either the channel length of the applicator itself, or sometimes it's the channel length when coupled with the associated transfer tube guides. And on that Excel spreadsheet where you have all your applicators on there, you should record the measurements and compare that to the specification. Is it within tolerance? And then as you measure with your annual QA or quarterly QA, you can actually look at trends and see if anything changes. Next slide, please. Functional tests. First thing you do is assemble everything. See if it works. And if there's different ways of putting things together, different combinations, verify each mode of assembly. Also check the robustness and functionality of the assembled applicator. And it's tempting to skip that step, but it's really important. What happened to me once is that a physician broke a couple of applicators actually because he wasn't clear about one point of the assembly and put too much load on a part of the applicator. So if you assemble this before the applicators get sterilized and practice this with your team, everybody knows how to do it correctly. You should check the connectivity to transfer guide tubes. Some vendors have designated transfer tubes that are used with specific applicators. So they have one transfer tube for the ovoids, one transfer tube for the tandems. And check that there's a good connection, and check also that if you don't connect correctly, that your HDR afterloader interlocks and says, hey, this connection isn't working correctly. After you have everything connected, run the dummy wire to check for internal obstructions. Sometimes in the connectors, these little gates that they have, sometimes they wear out mechanically and you can't really tell until you reconnect the transfer tube to the applicator and run a dummy that this is the case. Okay, next slide, please. So imaging tests. So what you're looking for there is mechanical integrity and see if there's any materials defects that you can pick up that are internal, bubbles in the plastic and things like that. So what you do is, if you have a good way to radiograph it, you can do it on a radiograph. On a Linac kV imager, for example, a good setting is 70 kVp 10 MAS, and you get a good picture on your epi. On the CT, we find that often that a scout scan works really well. And what you also should do for the applicators is image them once without the dummy wires, as it's demonstrated on the upper left. So you can really focus on the materials. And then the second thing is you put the dummy wires that the vendor provides in there. So you can also visually verify that the dummy wire sits central in the channel and goes all the way to the tip as indicated in the technical instructions. Next slide, please. I've had a hard time with KV imaging and doing autoradiographs on the same film. And somebody taught me actually that you can do imaging tests using electron beams. I had no idea. I learned that a year ago. So when we set out to radiograph our applicators, and we wanted to do this on film because we then wanted to overlay the autoradiographs later, we couldn't get enough dose from our KV tube. And two colleagues actually told me, Dan Skanderbeck from UC San Diego, he's lecturing later, and Joanne Priscendero from University of Michigan, they both told me you can use electron beams. So two settings that seems to work is 9 MV, 20 by 20 field, 100 SSD, and 350 MU. That's what I use. Or 12 MeV, 20 by 20 field, 100 SSD, 600 MU also works really well. And the way we've done that, actually, we've taped the film on the printout from the applicator model library, scaled correctly. And then we took a radiograph to check for mechanical integrity. And then we took this whole assembly and did an autoradiograph later so we could verify the positions of the source on this film. Really neat technique, brand new to me as well, and I just wanted to share that more widely. Okay, next slide, please. So when you have applicators that have more of a volume, like ovoids and cylinders, multi-channel cylinders, I recommend doing a full CT image of the applicator. And import these images into the treatment planning system and measure, like you see in that image below. So you can verify that there is no scaling issues. You can also do this using the radiograph. If you used 2D planning in your treatment planning system, you can also import the radiographs. So check for correct dimensions, both for the image itself and both for the applicator. Okay, next slide, please. So this one is tricky, the offsets. So the offset is defined as the distance from the outer tip of the applicator that you can see on your imaging study or physically to the center of the first most distal source position. That's what we mean with offset when we talk about it in this lecture. Make sure that if you read manufacturer documents, what they mean with offset. This is how we're going to use it here. So the offset is a safety clearance because you do not want to run your source into the very tip of the applicator here. You want to have a little bit of white space. And in the offset distance that you want needs to be incorporated in the applicator and the treatment planning system. The manufacturer will provide you with a nominal offset value for each applicator that they recommend. But you must verify this offset by measurement, by actually taping the applicator to film, doing a treatment plan, doing an autoradiograph of this first source position on film versus the tip of the applicator to verify that you have the correct offset. Next slide, please. This is really, really important part because if you get this incorrect, you get it incorrect for every single patient you're treating. So really, really important. There's multiple ways to go about how to do this, and all of them involve some kind of film and or imaging. Next slide. And will show you a couple of methods. So double exposure method that I talked about earlier is preferred. So that's first you take a radiograph image of the applicator like we talked about before, either with KV on EPIT or actually with KV on film or with electrons on film. On the same film without moving the applicator, and that's a bit tricky, lots of tape involved, you run the HDR source to the most distal 12 position at the tip of the applicator and leave it there for several seconds. I usually use 2 to 3 seconds per dwell position with gaff chromic film. And then I pull back dwell positions every 1 centimeter from the tip just to have a good image of the whole process. So you can see this on the left side, you see the needles in this case taped on film. In the middle, you see the combination of radiographs, that's the faint line, and the autoradiograph with the dark source positions. On the right-hand side, you see the same for gaff chromic film. Now you can see that the applicator tip, especially for plastic applicators, are really, really hard to see. And especially once you have the autoradiograph, that black dot from the source on there. So what we have taken to, and I think I have a picture later, is after the radiograph where you still can see the tip of the applicator and you have it taped, we take a very, very fine permanent marker, the finest we can find, and physically draw a line on the film to mark the applicator tip as well. Next slide, please.
Sonja, can we stop for a second? We'll field a couple questions.
Sure.
This has been really helpful so far, so thank you. So we've got a couple questions in here. I'll save them for the group. We've been discussing in text a little bit here. So a little bit more about the electron beam. So I think a few people have found that very, very beneficial or very helpful information. I know I used it for the first time this year as well. And one of the participants wanted to know, what are, again, to reiterate, what are the benefits of using electrons rather than KV?
Yeah. So in my case, I don't have the silver bromide film anymore, the traditional film we used to have. We don't have a film processor, so I have to use gaff chromic film. And gaff chromic film, with gaff chromic film and plastic applicators, it takes a really long time for KV images to produce an image on the film. I haven't found a good, one moment my son is about to storm into the room. So I haven't found a good setting, and it takes a really, really long time also. And so with electrons, you literally shoot a few hundred MU. It takes a couple seconds. Hi, Johan. I'm giving a lecture. Why? I'm teaching some people. I'm teaching people how to use brachytherapy applicators. I'll come down to you later, okay? Yeah. Yes, when I'm done with that, in 40 minutes. Okay, love you too. I'm sorry. Energetic 7-year-old. Yeah. So it takes a very long time with no. It takes a long time with photons. With electrons, the whole process is just a lot faster. Yeah. With plastic applicators, especially. Mm-hmm.
Yeah, and I think you can really see the applicators much better as well with the electrons. And another cool thing is that I use them on my titanium applicators as well. And I get really, really well with titanium.
It's good to know. I don't have titanium applicators anymore, so I couldn't test that. Yeah.
Sure. Later at the end of the presentation, I can share a couple images for those who are interested. And one more question here at the end. Is it okay to use expired film, or does it have to be new film that's still within calibration?
You know, for this purpose, because we're not measuring dose, I've certainly used expired or near expired film, to be honest, but you really need to check if the film has darkened or has had any temperature exposure, especially if you use GAF chromic film. So if you have any darkening of the film, that impacts your image quality. If you have really well-maintained film that has been kept at temperature and in the dark, and it's not too long expired, I would say for this purpose, it's okay. Yeah,
very, very good, Sonja. I completely agree. And I'll just make one more point before we move forward, just about these autoradiographs and offsets. This will be, a lot of the base for your treatment planning. So you want to make sure that you're getting this right. So just to reiterate some of Sonja's points, one, look in your applicator manual and see exactly what the expected offset should be, and for a given, for that dwell position. So for example, if I look in my manual and it says at 1500 millimeters, it's supposed to be exactly 12 millimeters from the distal tip to the center of the first dwell position, then I'm going to take that exact setup. I'm going to send it from that particular case to 1500 millimeters. I'm going to do an autoradiograph, like Sonja said. I'm going to mark the tip of the applicator. I should be able to measure with a ruler that exact 12 millimeters. So this is really important.
Yeah, I just want to follow up with that. I actually made a mistake with that last year when I got my new applicators with a multi-channel cylinder, where I missed that for this particular vendor I was switching to, the offset was different for the central versus the peripheral channels. And I planned it in my treatment planning system for the autoradiograph as equidistant, and the films came up a centimeter offset, and my resident and I were scratching our heads, and eventually we dug back into the manuals and we go, oh, we indeed need to have a 12 millimeter different offset for the peripheral channels. And if we hadn't, and it was different with the multi-channel cylinder from the previous vendor. So if we hadn't done the autoradiographs, we could have made an error in the patient treatment. So drives home, it's really important.
Yeah, very good point, Sonja. Thank you.
I should get a scan of that film in this lecture to show what happens.
Yeah, that would be great.
Yeah. Okay, next slide, please.
Okay, yeah.
And that's why we do it. We figure out the things we don't quite know. So if you don't have KV imaging and you didn't know how to do it with electrons, I've seen people just do it with films and just marking the external applicator tip location. So you can see here the very fine drawing of the applicators on paper. Or as I showed you before, if you have an applicator library, you can print out the applicator shape from the library and tape the film to that. And same from then on, you do the same thing. You send the HDR source to the most distal position, a couple other positions at 1 centimeter distance, and you measure the marked end to the center of radiation for the first dwell position. And as you see on the film on the right, label your film in all possible details so you know a month later what you have in front of you. Next slide, please. So this is actually taped to our wall behind the treatment planning system. This is the applicator commissioning worksheet. So I have there's the vendor part number, the description, what it is, the center of the source to the outer wall, that offset, the left is the one that you measured. In the middle line is the nominal offset that the manufacturer gave you, and right the difference. And so you can see that for different applicators, there's some manufacturing tolerance, and you want to take this into account when you're treating. I personally, if I near a millimeter offset between what I measure and the manufacturer gives me, I talk to the manufacturer, because that is more than higher than I would expect from current manufacturer accuracy. 0.2 millimeters, 0.3 millimeters is pretty normal to find. Above 0.5, I'm starting to get concerned and will probably repeat my measurement. And if it's reaching near 1 millimeter, I talk to manufacturer to see if there's an issue. Okay. Next slide. Also, I talked about that before. You also have a check ruler that you should use to measure the internal length with either with the applicator combined with the transfer tube, or just the applicator itself, depending on your manufacturer. And also have this very same table for every device you own, put in the expected length, the measure length, and the difference. And again, 0.1, 0.3 millimeter, up to 0.3 millimeters different is probably okay. If you go higher, if you find 0.5 millimeter and a higher difference, I would start checking individual components and start talking to the manufacturer. Next slide, please.
Good, Sonja. I'll just make one extra point on this slide. So with like Sonja said, all manufacturers will have some sort of length measurement that tests either the applicator length or more typically the transfer tube plus applicator length. And one thing to make note of is our gold standard is the autoradiograph, right? So like Sonja taught us how to perform the autoradiograph and make sure that offset is correct. Once you verify that offset is correct, less than a millimeter, and like Sonja said, preferably less than like half a millimeter, at that point, you then measure with the sort of manufacturer length guide, whatever sort of tool that is. And depending on the situation, so for example, if you've got like a nucleotron system, which I'm using right now, sometimes there's some wiggle room. Or if I'm measuring, especially like, a curved tandem that has some space inside, or a ring or something like that, the length that I measure is a little bit dependent on how hard I press. And especially if it's like a ring, I can press it and really make it bow out, and I can get some different measurements. So one of the main things that I look for, depending on the system, is consistency. And so, for example, back to my applicator, so I've measured exactly 1,500 millimeters for my system. It might be different for yours. Each manufacturer is different. And I saw that my offset was perfect. And then I put in my length guide simulator through my transfer tube and applicator, and it measures 1,502. But that's okay, because my gold standard was the autoradiograph. And now when we go to the machine, every fraction for every patient, we measure that combination of transfer tube and applicator. And we look for just that it remains consistent at the 1,502. So again, our gold standard is the autoradiograph. And this other tool may or may not align perfectly, but as long as we're looking for consistency in results as we go further.
Yeah. And actually, when you do that, you mentioned bend applicator with bend in it. If you have a bend in the transfer tube, the same thing happens, that the ruler device goes in on the outside of the internal diameter and measures a longer length. And so you can really see how important it is to get the transfer tubes lined up as straight as possible when you do QA tests and also when you do patient treatments. Yeah. Okay, next slide, please. Okay, we have a poll question here. What is the nominal channel length for a tandem applicator? 130 centimeters, 1286 millimeters, 121.4 centimeters, or it depends on the manufacturer. We had some challenges last time to run the poll. If it doesn't run, we can just go by. Ah, there it is. Yay.
We've got 30% responses, so we'll do another 10 seconds.
Mm-hmm.
Okay, I'm going to end the poll now.
Mm-hmm. And yeah, it depends on the manufacturer. There are differences between the system. So the vendor I had before, until last year, 130 centimeters would have been correct for me. Now it's actually a different answer. And so it depends on the manufacturer, and you should make sure that you know for your system what that is. Thank you. Let's go continue with the lecture. Transfer tube, we often overlook them. It is really, but they're very, very crucial because they're part of the overall system. So it is important to handle and store your transfer tubes appropriately. Transfer tubes can stretch over time, especially if the connectors are fairly heavy compared to the diameter of the tube. Depends on the design. So the ideal storage is actually to keep them stored straight and flat. As I also just mentioned, you should try to run your transfer tube straight and not too much of a mess there. So the left side of the picture, I'm lacking the English word now. So the left side, you see a picture of very well connected transfer tubes. They run straight into the applicator. There's just minimal bend in there, and they don't cross over too much. On the right side, the transfer tubes look like my yarn when my cat after my cat gets into string. This is less than ideal because the bend in the transfer tube makes the source run out on the outside diameter of that bend and changes the length of the channel slightly. Also, when you check the connections, it is much harder to check on the right side because you have all these crossing transfer tubes than on the left side. So try to be nice, neat, and tidy with the transfer tubes as best as you can. Okay, next slide, please. So delivery tests. Deliver test plans with a dummy and check source and an actual source driven into the applicator, and make sure that each combination that you get for your applicators that you're planning to use clinically is actually deliverable. There are no errors from the afterloader and no obstructions during delivery. I learned on Friday the hard way that it's very important. It's probably from use. The channel 7 connector from transfer tube to my afterloader went bad. The afterloader was not able to detect the transfer tube that I put into channel 7. So I had to take that channel out from planning and call in the service engineer. Now, when you get a new machine, you need to check exactly that. Does the afterloader correctly identify transfer tubes that are connected to each of the channel? Because these little connectors in the face of the applicator that you see here, they can shake loose in transport, and they can also get mechanical damage from wear and tear if you do a lot of in and out of the applicators over time. And that's why we check this at commissioning and also at annual QA.
Sonja, speaking of wear and tear, we've got a good question. If you don't mind answering.
Sure.
Trying to answer. What is the clinical lifetime, for transfer tubes or for applicators?
I think I have a slide on that later, but just to say, manufacturer usually specifies what they consider the lifetime limit. I've just changed manufacturers, so my memory can be for either one of them. I think one of them specified 5 years for the transfer tubes. The other one specified number of sterilization cycles. For the applicators, it also depends on manufacturer and what type of applicator you have. So for example, for my previous manufacturer, they specified 500 sterilization cycles for the cylinder and 300 sterilization cycles for the tandem and ring as their lifetime. And my current manufacturer, so those were for titanium applicators. And now I have plastic applicators, and the manufacturer specifies 3 years. Yeah. Very honestly, for cylinders, which are essentially very solid pieces of plastic, I have used cylinders longer than the 500 sterilization cycles. I just did very, very careful QA on them. I did radiographs, physical inspection, and I did that on a every 6-month basis. But yeah, if you're tight for resources and you do really careful QA, you really have to. It's less than ideal, but sometimes we need to have judgment calls.
Yeah, I think that's a very good answer, Sonja. I agree with you as well.
Tandems, I can't really see when something, when materials weaken, that's much harder to say in a tandem, and it's much thinner material. So I really don't recommend going over the life cycle for those. And it's much gnarlier if something goes wrong with those. Yeah. Okay. Thanks. Good question. Yeah. Caution with Varian Varisource systems. And this is a slide. So the internal channel length, excluding the transfer tube tip, so it's usually 1.4 centimeter, is used for treatment planning, not the measured value. So you can see here in this slide that there is a measured value for the length, but because you have this transfer tube tip that's not there when you, that gets taken out of the system and you connect it to the afterloader, there is a 1.4 centimeter difference. And you need to be aware which value you need to put in the treatment planning system. I hope I said that right. It's been 12 years since I've worked on a Varisource. So yeah. So make sure that you know the difference between measured and treatment planning system length. And that's explicitly specified in the instructions for use that the vendor gives you. There's a lot of numbers you've heard flying around: the overall length as measured, the length in the treatment planning systems, the offsets. So what I have done to make it easy on the dosimetrist and the physicist checking the plan is I've put together a parameter sheet for the planning area, and that's literally taped to the wall. So I put in for each applicator which channel they're mapped to, the length of the system that we need to put in, the offset, and then for some applicators, sometimes we can CT with the dummy, sometimes we don't have the dummy, so we can't see the internal length. So you can see here for the plastic needle, for example, at the bottom, if I have a dummy in there, I can actually identify where the first seat position is by dummy, and I can use the CT to insert a distal mark. If I don't have the dummy in there for some reason, I can still see the tip of the physical applicator, and I have a physical offset I put in my treatment planning system. So we figured this all out. We have it double and triple checked so that not just one person does this, because it's really important to get that right. The biggest errors in HTR treatments these days is inaccurate programming of channel length, leading to geometrical miss. So in the United States, if you look at the reports on the NRC for any errors that had happened in HTR, by far the most is getting this wrong. So as Adam said, always measure the channel length prior to treatment, put it down, write it down, and compare that to your treatment planning system. Some HTR systems actually have this automated these days with a dummy source, and that is very helpful. And just as you check the plan, verify the nominal length and treatment planning parameters very, very carefully. Okay. So cheat sheets are okay, they're encouraged. I wanted to talk about using libraries. In a lot of the treatment planning systems these days, you have libraries of solid applicators, and they are created by the manufacturer from the CAD drawings. Sometimes the user can even put them in. And they can be used, I should say, I think they should be used for treatment planning if you have that available, because it helps you in reconstructing the standard applicators with a fixed geometry. So you can see here on the lower left image, you have this multi-channel cylinder, and the internal channels are already marked correctly in the applicator library. So you're guaranteed that you get the offsets correctly, and you just need to adjust for your measured differences from the autoradio. So to use these, you have to verify that take an image of every applicator you have with your CT, and then bring this into the treatment planning system and overlay your applicator from the applicator library and make sure that coincides, and verify that at commissioning. I actually have another story about that. Also happened last Friday. I had a very interesting Friday on my brachy system. We used a applicator that was new for us, and when the dosimetrist pulled in the applicator from the library, the dosimetrist actually grabbed the incorrect one, and there was a 1 centimeter difference. And they called me and said, hey, the applicator doesn't agree with the dummy wire. And I came in and we immediately saw what the issue was and put the correct applicator in. But this just shows you that first of all, when you make an error, it's very easy to identify that you had the wrong applicator because it's a standard geometry. It's fairly easy to fix. And with a manual marking of the applicator, we might have made an error because we had the wrong applicator model. So very important to use these, but once you have them commissioned, it's actually much faster to plan and much safer because you're less likely to make errors. Okay, next slide, please. Training. Very, very important. Train everyone on the use of applicators. And I talked about this physician who forgot a part of his training and put undue load on a fragile part of the applicator and actually broke a couple very expensive applicators. So train your physicians and therapists, anybody who handles the applicators, on how they get assembled correctly, which order, where to put pressure, where to avoid putting pressure. Have a vendor train the physician on handling the applicators during insertion because you have a much more limited area you can work in. And train your therapists and nurses on the care of the applicators, how to take care of them. And also whoever plans your treatments, be it the physicists or the dosimetrists, train them on how planning goes for the specific applicators, like talk them through the offsets, show them the library. Thank you. Show them the library and make sure they understand and answer all of their questions as they come up, because it's fairly complicated, especially if you have a lot of different applicators. I actually went over to central processing, which is where our applicators get sterilized, and showed the people there how to handle and care applicators for the applicators to make sure they also know how, fragile these products are. Because surgical instruments are always made of titanium. They're much more robust than often plastic applicators. So we also gave the folks that sterilize applicators for us the instructions for use, so they know how to do that. And we also have them available on a shared drive so everybody can find them very quickly. You can get these instructions for use from the vendor websites. You can sign up there with your email account and you can download them and also get updates if they get updated. Next slide, please.
Yeah, and I'll just reiterate that point. This is something that doesn't seem like medical physics work, making sure that sterilization knows how to sterilize things right. And I think a lot of us in our careers have sort of skipped over that point pretty quickly, or maybe we didn't communicate very well, and you can end up having applicators broken and that sort of thing. And if you've only got so many applicators, that's a really important point. So definitely make sure that you find that information in your manual. If you can't find it, talk to your vendor and go over to sterilization, find the manager, make sure that that process of sterilization is implemented correctly.
Mhm. Yeah, one thing I've learned the hard way is we had sometimes little pieces that the sterilization people folks interpreted as single-use items when they were reusable and threw them away. So I have pictures of every sterilization tray, what that should look like, and a list of components in there. And I gave them to central processing so they know what is reusable and what is single use. So saved me a lot of money over time. It was work, but yeah. Next slide, please. I think there's one more. Sterilization, yeah. We dive into that. Sterilization instructions. The manufacturer gives that to you, and it's also on their website. Usually the manufacturer provides these sterilization cases, but you can also order them. They have very clear guidelines for allowed sterilization techniques, temperature, pressure, exposure times, dry times, everything. So communicate that to the staff, and again, give them pictures of what should be inside so they know which components are reusable. Okay. And yeah. Annual, when we're commissioning the system, we're taking baseline. As Adam said, especially for the length, overall length of the system, there is some tolerance in there, but what's important is that things stay constant over time. When we develop an annual and quarterly QA program, I use the Code of Practice for Brachytherapy Physics from AAPM Task Group 56. I hear that IAEA is preparing an updated document, but that's not out yet. They have very nice tables, specifically Table 2 and Table 3. Table 2 is for intracavitary source and applicator QA, and Table 3 is for interstitial source. And it tells you exactly what you need to do, what your endpoint is, why you're doing this, and how often you should do that. Most tests are at least annually. I would say if you have a very, very busy program and you use certain applicators a lot, you should consider doing these tests quarterly. So, for example, if you have a very busy tandem and ring program and you have plastic applicators, it might be worth doing quarterly checks on that. More often cannot hurt. If you can at all do and you have a busy program, it's worth it. Okay, do we have another slide? Poll question number 2. What's the offset of a treatment applicator? The distance between the tip of the inner lumen and the tip of the source, the distance between the outer tip of the applicator and the tip of the source, the distance between the outer tip and the center of the source, or the distance between the inner tip. Don't be afraid to guess or get it wrong, because that's what learning is all about. We check ourselves and see if we got the right understanding.
Okay, I'm going to end the poll. Here results.
That was a tricky one. You had to read it really carefully. So the offset is defined as the distance between the outer tip of the applicator and the center of the first source position, number C. And I think we'll share the slides with you. You can see that in one of the earlier slides, there's actually a drawing what the offset means.
Yep, very good. And the presentation will come to a conclusion pretty soon, but maybe this question on offset is a good time to answer one other participant's question. It's a really good one. How do you QA, say, your marker wires? Are you supposed to QA your marker wires, and how would you QA your marker wires if that's what you use for your treatment planning?
Good question. Yeah, very good question. If I have existing applicators and new marker wires, I can just do a radiograph and see if that matches the old marker wires. For complete new system, that is a lot trickier, because what I have done for my new system is I had a technical drawing of the marker wires from the manufacturer, and then I used both a radiograph and a ruler to both geometrically measure it and radiographically measure that the markers were at the correct distance at the tip. There's a slight offset in my marker wires, and that they were at the correct distance from each other. Yeah.
Yep. So good question and good answer. So
it's yeah.
And we actually use our marker wires here. So there are a couple of different methods. So like Sonja said, that's a great method where you can basically measure your offset with your marker, measure your offset with your autoradiograph, make sure that they're the same to the center of both sources. If you get your technique right using electrons, like Sonja suggested earlier, you can actually take an autoradiograph, or I'm sorry, you can use your electrons to make an exposure on your gap chromic film with the marker wire in it. You'll see the outline of the applicator. You'll see that first marker looking bright on your film as well. And then after that, you'll take an autoradiograph, and you should be able to see centered inside of that dark exposure on the film. You'll be able to still see that marker, the marker wire with that little dummy dwell position. You can see that they overlay perfectly. So yeah, very, very good question. So multiple ways to get to there.
It's actually a good comment on everything here. There's multiple ways to do this applicator commissioning. So I just wanted to say something about rings. The source dwell positions in ring applicators have been shown to deviate from intended positions by up to several millimeters. And that's discrepancy originates from the thin diameter of the wire compared to the ring lumen. And that's causing different possible paths in the applicator. So what happens is when the source wire goes into the ring, you push it in, it goes along the outside. And then when you pull the source back, the first few millimeters, it's just the source wire tightening in the ring, going to the inside of the lumen and then pulling back. So that's the origin of that. And this is why it's so important to quantify the actual source position inside the applicator. The combination of autoradiograph and radiograph for the tandem and ring is really, really crucial. And different vendors have come up with different solutions how to compensate for that issue. And that also depends on which ring applicator design you have. They actually differ. I know for Varian, if you have a titanium ring or plastic ring, they look very different. Because this is a very complex topic that will require a lot of attention to detail, we decided to cover that in a separate session. Okay, so we're not going to talk about this today. As for references, we have two task groups. The Code of Practice for Brachytherapy Physics, task group 56, I mentioned that, has very good tables on when and how often and what you need to QA. Comprehensive QA for radiation oncology also covers HDR afterloaders. Task group 59 goes a little bit more specific in high dose rate brachy delivery. And there's also a paper on high dose rate brachytherapy QA, a very practical guide, and we'll give you the reference here as well.